Okay, this is review for the trig test. I'm just going to go through it as quickly as possible and probably make a couple videos because it takes forever to upload if I don't. Okay, so when you're doing a trig expression, one of the things you always want to look for is trig identities. So sine squared plus cosine squared, you should know, is 1. So that's 1 over cosine of x. Since that's not one of these choices, then 1 over cosine of x is secant of x. Okay, so it uses a couple properties that you should know. This one right here, so you might have to do a little, work. So everything's in terms of sine and cosine. So what you need to do is try to use some identities. Now, if I change sine squared, but you can, anything you feel like you want to do, you can do as long as it's accurate. But sine squared, you can make 1 minus cosine squared. Well, the problem with that is that seems more complicated to me, so I won't do that. So then what I'll do is I will add these two fractions. To add fractions, I need a common denominator. So I multiply the top and the bottom by cosine of b. So I'm left with cosine of b is on the bottom. So cosine of b is on the bottom, and then this is sine squared plus these two. Multiply cosine times cosine, you get cosine squared. This is exactly the same as number 1 now. So now it's 1 over cosine of b. But in this case, they give us 1 over the cosine of b. Number 3. Again, I like to put it in terms of sine and cosine first. So secant is 1 over cosine. Tangent is sine over cosine. This is a division sign. So when I do this, this becomes keep the first one, change division to multiplication, and flip this. Keep, change, flip. Okay, when I do that, the cosine of b's cancel out. This is multiplication, so 1 on the top and 1 on the bottom cancels that out. I'm left with 1 over sine b. That's not one of the choices. So 1 over sine b is oh, sorry, it should have been I don't know why I switched to b. Anyway, 1 over sine b is cosecant. Theta. I'd redo that, but I just don't want to. Alrighty, next one. Number 4. Again, I like everything in terms of sine and cosine, but again, you can do whatever you want, as long as it's accurate. Since this is a fraction, one of them's a fraction, I like to make them all a fraction. It just makes it easier for me. Then I multiply these through. When I multiply, this one stays on the top. Remember, multiplying fractions is no problem. Multiply tops, multiply bottoms. So this is a top, so this becomes cosine squared over 1. But cosine over cosine is 1, so 1 minus cosine squared is the answer. That's not there, so we know that 1 minus cosine squared is also known as sine squared. Okay, we did a bunch of these that look like this when you multiply this out. 1 cosine of x, 1 minus cosine of x. This is 1 minus the cosine of x, and then this is negative cosine squared x. So when I add these together, the middles drop out because they are conjugates of each other, and that always happens. I'm left with 1 minus cosine squared, which is, where'd you go? Sine squared. If the terminal side of an angle is in standard position, lies in quadrant 3. So basically, do you know what angles lie in quadrant 3? So these 120 ends up here. Nope. Okay, because we're measuring this way. So then if I want to do, hold on. So 120 isn't the answer. So let's try, I like to do the positive one first. Negative 240. So negative 240 would start here and go down. That's negative 180. So I'm going to go past this, and this is going to be in quadrant 2. So that doesn't work. All right, so then 110 I'll do over here because I'm confused. So this is 90 negative 90. So 110 would be somewhere in here because this is negative 180 and that's negative 90. So there we go. Is that the end of this page or is there more? Okay. All right. So these, you want to find which one of these lies in quadrant 3, 4. I knew that. It says 4. Of the coordinate grid. And you have radian measure. So unfortunately, you're probably going to have to convert each one of these. So I'm going to pause it for a second, convert them, and then come back. Okay, when I converted these, I got 216 for this one, 135, negative 120, and negative 420. So I do like these to be between 0 and 360 or negative 360. So I made the coterminal one, and I added 360, and I got negative 60, which does turn out to be the answer because negative 60 is right in here somewhere, quadrant 4. Okay, coterminal, remember with the coterminal, we take 915, and we want to get to see if one of these numbers, which is less than it, are coterminal. So I'm going to subtract 360. So I got my calculator right here, and I get 555, not even close. Subtract 360 again. I get negative, oh, no, I get just positive 195. There it is. You can see if the other ones are, but if I subtract 360, I'm going into negative territory, so that's not going to work. Okay, again, coterminal, negative 557. I'm going to add 360 because I want to be positive. These guys are all positive, so 557. Add 360. Negative 197. That's not this one. Chances are that one's not going to work. Add 360 again. 163. Which is that one. It does surpass these two. It doesn't even come close to hitting these two. And this one, it looks like it might, but it's negative, so that doesn't count. Okay, number 10. Convert that. Remember when we're converting 2 radians, the pi's in the top. Now we want to keep this in terms of pi. So I just do 600 divided by 180, make it a fraction, 10 pi over 3. Sorry if I may make a mistake on any of these, but whatevs. I'm sure you'll tell me. Again, I want to convert to 2 radians, so I do pi over 180. But notice there is no pi in the in any of these answers. We want it to the nearest tenth, so I have to put 162 in the calculator times, and I actually have to put pi. Remember, pi is second, the tilde to the whatever caret button. Pi divided by 180. Which is 2.8274, so 2.83. Okay, expressing this in degrees. We want to convert radians to degrees. It's always 180 over pi. In this case, the pi's cancel out. Multiply these two together. I get that. Okay, same deal. 11 pi over 6, negative 11. This is a joke. They shouldn't put anything positive. That doesn't even make sense. 180 over pi. Put that in the calculator. Negative 11 divided by 6 times 180. Negative 330. All right, that was the end of that. All right, this one, and this one tends to be the one that you guys, I don't know why you get so confused, but this is negative 1.5. Yes, there is no pi. It doesn't make any difference. Pi is just a number. Okay, it's just a number. So I have to do 180 over pi. It's like 180 divided by 3.1415, yeah, etc. It Doesn't matter that the first one, this one doesn't have a pi. It's already, you know, been incorporated in it. 180 divided by pi. Remember, pi is second caret thingy. I get negative 85.9. Oh, that's awesome. To the nearest tenth, so 85.9. Negative. Okay, if this is negative, then the degrees are negative. That doesn't change. All right, this one you got to skip. Sorry. It's not, it shouldn't have been there. Sorry. There's nothing over there. All right, 16. What are the coordinates of the point? Now we know that this is, the radius is 1, so I could draw a circle, and that would be the unit circle. So when that's the case, we know that the x coordinates are cosine and the y coordinates are sine. This is quadrant 1, so it's positive, positive. Okay, here we are in quadrant 3. So if any of these weren't in quadrant, any of the answers weren't in quadrant 3, you shouldn't pick them. And you should know these guys by heart. So this is cosine of x is equal to radical 3 over 2. So which one is that? Well, that is 30. How do I know that? Because I have it memorized, and if you don't, sorry. So that means that this angle right here, this little one, is 30. So this is 180. Plus 30 is 210. I just hope I got that right. Sorry. 30, yeah. All right, this one, these are all basically the same thing. So things that you should look for here, this is 30 degrees reference angle. We're in quadrant 1, so if they did have anything being negative here, you could cancel those out, but they're positive also. You just have to know that the cosine of 30 degrees, so remember that's the x-coordinate, the cosine of 30 degrees is radical 3 over 2, and the sine of 30 degrees is a half. So that's the one we want. If you don't have those memorized, then this is darn near impossible, especially from memory. So we have an angle in standard position. What's the exact value of cotangent of theta? So if we draw this, this is 0, negative 1. So what angle am I on? Oh, it doesn't really even matter. But it is 270, yes. So this is 0, negative 1. We know this is x, this is y, which is cosine and sine of the whatever angles there. So I know cotangent of theta is cosine over sine. So cosine is 0, sine is negative 1. So it is 0. Okay, trying to find a quadrant here. So if we're doing a quadrant, it doesn't really matter what the number is. What matters is that sine is negative here. And it also says that cosine is less than 0, so cosine is negative. So remember this. What two quadrants? I'm going to do this one first. Sine is negative in these two. So those two stay. These two stay, and these two gets crossed out because sine has to be negative. And cosine is negative. Well, cosine is positive here, so it's got to be quadrant 3. Okay, same deal with this one, but you got to do a little bit more. So they say tangent is negative. So first we'll figure out the sine, see if we can cross out a couple of them. So tangent is negative, so it's not this one or this one. We want to know what cosine is. Oh, it's in the second quadrant. Look at that. Okay, they just told me. Awesome. So you want to know what cosine it is? So cosine is negative, so it can't be this one or this one. Tangent is sine over cosine. So it's we should probably go over, probably more accurate to just say opposite over adjacent. So if I make this theta, opposite is 2, adjacent is 3. So doing the Pythagorean theorem, so that's 4, 9, that's going to be radical 13. Remember, it's 2 squared plus 3 squared equals x squared. This is 13. It's a little messy, sorry. So x is radical 13. We don't need the negative 1 because it's geometry. So we have, so this has got to be the answer, regardless of rationalizing the denominator or anything else that happens. This is the one with the radical 13 in it. What is the reference angle? So we like to convert here. So this is 14 pi over 3, 180 over pi. Did all that, didn't have the calculator on. 14 times 180 divided by 3. 840, really? Okay, so we got to find the reference angle for that. I don't even know where that exists, so I'm going to subtract 360. That's 480. I'm going to do another 360, get 120. So that's right here. Those were all coterminal to it. So I know that is this terminal side is exactly the same, so they will all have the same reference angle also. So the reference angle is, okay, always with the terminating side and the x-axis. So if this whole thing is 180, this is your reference angle. So I have to do 180 minus 120 because I have to take that out. So I'm left with 60 degrees. Okay? They're asking for reference angle, so you should have been able to cancel out or cross out those negatives right away. And then 60, if you know that one by heart, it is pi over 3. If not, you got to convert. All right, we're going to stop this video here and do the next 4 pages for the other one.